I'm Ryan. I'm a science teacher.
I'm Cheryl, and I slept through science.
Each episode will tackle a science question you may have learned in school, but can't quite remember or fully explain.
And I'll take the risk of asking the dumb questions so that we can all understand the science we slept through.
The bell has rung. Let's get started. Welcome to lesson 28. We are in our color unit. Do you have a colorful question this week, Cheryl?
I definitely do. You know, as we've been doing this color unit, I just have colors on the mind. Just been noticing them out in the world, in nature. And then I was driving on the freeway and I saw not a partial rainbow, not even one full rainbow, but a full double rainbow.
Oh.
It was very exciting.
That is exciting.
Yes. And what the heck? What's up with that?
What's up with what?
Why do we see rainbows?
Why do we see rainbows?
Why are they in the sky? What are they doing up there?
Okay, so why do we see rainbows? Where do rainbows come from? Is that sort of the question?
Uh-huh.
All right, well, let's start with the pre-assessment.
All right.
Let's just start with where do you see rainbows? You mentioned one place already.
In the sky is the most common. Also, sometimes maybe like in a sprinkler on a sunny day.
Okay.
For moments. I mean, there's other times where you can see like a little teeny rainbow. But the most common is in the sky, in an arch from like horizon to horizon, or whatever you can see of whatever your horizon is, I guess. And, and it's in an arch where I'm guessing it's an actual like perfect half circle. And if you could see the rest of it, I'm guessing would be a perfect circle.
Okay.
And then, the double one is the same angle, just smaller. I can show it to you.
Do you have a picture?
I did take a couple pictures while driving, but we've already established I'm a bad student, so we're just going to say I'm not a great influence in general, and we're just going to disregard that point. But I am going to share my screen with you, and anyone who is watching on YouTube can check out this photo.
Wonderful.
So that's a piece of it.
Okay. Wow. It looks like it's coming from the road itself.
I know.
Oh,
it looked like it was coming like from these trees.
Yeah.
And you can see like the whole thing on the left side. It's more faint, but it's there.
Okay.
And actually the fainter double rainbow, I was saying it was on the inside. It's on the outside. I don't know if that's how it normally goes or not. That the more faint one is like that. Maybe it just depends on shadows and lighting. Who knows? But you might know.
The more faint one is
further on the outside
instead of on the inside.
Yeah. Do you see how this one further out? A larger arch is much more faint.
Okay.
Yeah. That's the rainbow I saw.
Okay. Did you notice anything else about the two rainbows?
They're bright.
Okay.
Well, I mean, it feels like they kind of moved as I moved. Which might be very hard to find the end of a rainbow, because if you went to where I saw the end of that rainbow, then it might look like it's in a different spot if you actually went to that location.
Okay.
But it's just light anyway, so that makes sense.
Unless there's gold at the end of the light.
Yes, but I mean, it's impossible to find, so.
Only because the leprechauns don't let us. Sorry, I'm diving into the lesson already. I should save that for later. All right. Where do you think the colors come from?
Well, I know it has to do with rain and water. I mean, I'm sorry, sun and water.
Okay.
which is why I might see it in a sprinkler sometimes too, or in my kitchen faucet, or things like that.
Okay.
I think it has to do something with the sun shining through water, which is why they appear after the rain a lot of times,
Okay.
or even I've seen them during the rain sometimes. So even like in this picture, the sun was behind me and
Okay.
the rainbow ahead of me. So I don't know if it's like the sun was shining through like a rain cloud, or some rain or some water left over in the air.
Okay.
Maybe.
Does the sun always need to be behind you?
I don't think so. I think the sun needs to be behind the water, and it's going to appear on the other side of it.
So the sun needs to be behind the water, but in this picture, it was behind you, not behind the water.
Well, I don't know where the water's from. I think the sun has to shine through the water, and the rainbow will appear on the other side.
Okay.
But I would imagine if someone was driving the other way on the freeway, maybe they also could see it, and they would see the sun. Maybe.
Okay. Okay. So you think that we've got to have sun and we've got to have water.
Mm-hmm.
Something about the sun going through the water.
Yeah.
What about the colors?
Well, we did talk about rainbow colors last week, but we didn't talk about why they are there. And I'm wondering if it the light gets fragmented into different colors. This is where I feel very dumb because I might be right. But I am not confident about that, and I could be making things up entirely. I feel like it's splitting up the light into the different colors.
What's the that's splitting up the light?
Whatever the light is shining through. Because there's also, aren't there like special glasses that do that? And like there's or even just it does that through glass sometimes. So I'm wondering if it does it like through the water. If maybe it splits up the light into different colors.
Okay. All right. And one final follow-up on this one is when you say it splits up the light into different colors, do those colors exist before they get split up, or are they made in the splitting process, do you think? Or maybe something else beyond those two?
This is 100% a guess.
Yeah.
I think they already exist, and we just don't see them because they're not separated. We just see light.
Okay.
And then I think they get split, but they're already there.
Okay.
I'm nervous.
Don't be nervous.
I feel like I really put myself out there. It's just one of those moments where I'm like, did I just look really stupid in front of the whole class?
Well, I think most of the rest of the class doesn't know the answer either, so I think you're fine.
Okay. Amazing.
We're going to start somewhere in the middle of what you've shared, though, and then we'll kind of work our way out to all of the different things that you talked about. Sound good?
So we're going to start kind of like around like the yellow, green, and then work our way to orange and red and blue and purple?
Yeah, exactly. That's definitely what I meant.
Okay, good. Good. Glad to hear it.
No. We're going to start with where they come from, like what actually causes the colors in the rainbow. And then we'll work our way out to like where you see them and why and some of those pieces.
Nice.
Sound good?
Yeah.
Okay. You said that rainbows come from the sun and water, and that is mostly true. The rainbows in the sky are definitely from those things. There are a few times where you can actually see rainbows from a few other things. I don't know if you've ever noticed, like in a parking lot, sometimes if there's oil on the top of like a puddle, sometimes you can see a rainbow color there.
Mm-hmm.
There are a few other places like that, but we're going to focus on the sky rainbows.
Okay.
And then you can make some inferences about some other rainbows that you might be able to see. What actually causes it is light going through raindrops. So just like you said, you need the sun and you need water. And both of those things are true. And in order to help you sort of understand, I've got some pictures for you.
Yay, visuals.
Visuals. And of course, I'll have links to the sources of and all of these things in our description so that people can come back and find them later if they're not watching on YouTube. Okay, can you see my screen all right?
Yes.
What we're looking at here is a diagram. So you've got the sunlight coming in from the left. We've got a raindrop. And notice that as the sunlight enters the raindrop, all of a sudden you see it kind of spreading apart and you can see those rainbows of colors.
Yeah.
Okay. You talked about the light being split apart or fragmented and that you thought all of the colors were already there. And you are correct.
Hey, that's exciting.
Yep, there you go. I know you were super worried and you're like, I don't really know, but you're exactly correct. White light is made up of all of the colors of the rainbow. And a rainbow is one example of how we know that. Because you can take the white light and you can split it up and end up having the different colors of the rainbow. So you know that they're there. What we talked about a little bit in our last lesson about just how many colors in the rainbow, we talked about there being different frequencies or different wavelengths for each color. Does that sound vaguely familiar?
Yeah.
Okay. Each color has a different sized wave. You can think about it. Do you remember which ones had the longer wavelengths, which colors, and which ones has the shorter ones?
Oh gosh. Oh, I don't remember.
It's okay. You don't need to. The red side has the longer wavelengths.
Okay.
And the blue side has the shorter wavelengths.
Great.
And what happens is as light passes from one material into another, like from the air into water, it affects each of those wavelengths slightly differently.
Ooh.
And what it'll do is this thing, and you can see it on the image here, it's called refraction, which is a bending of light. And I've got a really simple demonstration for you of refraction that you could repeat yourself if you wanted to.
That's exciting.
Okay. What does this look like in my hand?
A glass of water.
Correct. And what about this?
Oh, that's so funny. You got it ready earlier and I thought you had a straw, but that's actually a colored pencil.
It's a pencil. Yeah, I was probably holding it from the top.
Yeah.
Instead. Yeah. So no, it's not a color, it's a pencil. So here's what I'm going to do. I'm going to put the pencil into the glass of water and hopefully you can see this okay. Good so far?
Yep.
Okay. Now when I turn it sideways, what does it look like is happening to the pencil?
It looks like it's broken because it looks like on the surface of the water, it's coming out from a different spot than where it actually is in the water.
Yeah. Have you ever done this before or seen this before?
Yeah. Yeah. It was like a funny trick as a kid.
Yeah. This is refraction because the light is passing through the glass and the air at the top, but the glass and the water at the bottom. And so it actually bends the light waves differently.
Oh, that's why that happens.
Yeah. And so that's just a really simple demonstration of what refraction is. And so that's what's happening to the light as it enters the raindrop, is it's actually bending at a slightly different angle. But then as that light slowly bends at different angles, the different frequencies or different colors do that amount of bending ever so slightly differently. And that separates those colors.
Okay.
Then they actually bounce off of the back side of the raindrop, and that's reflection, just like a mirror.
Mm-hmm.
And so some of the light, but now by the time it gets there, it's already separated into those colors. And so then it reflects back to the front side of the raindrop, the same kind of side of the raindrop where the sunlight entered, but now down below at the bottom instead of at the top of the raindrop.
Mm-hmm.
And then it bends again on its way out of the raindrop because it's going now from water back into air. But it doesn't put them back into their colors. It keeps them separated. And then those light waves, now in different colors, are what reach your eye.
That's really cool.
You're still kind of processing this.
Well, now I'm curious about if a big old rainbow in the sky is like a bunch of water droplets all doing the same thing, like a projector. And that's why we see it versus like if one water droplet did it, maybe it would be there, but we wouldn't even detect it.
Yeah.
And then also if there's a second rainbow, is that like there's rain like higher up in the sky and it's doing its own thing? Or like why is there a double?
Yeah, great questions. Let's tackle the first one first. It is a bunch of raindrops. Just like you were thinking, if we just had one, you wouldn't notice it. In fact, for each of the different colors and each of the different points on the rainbow that you see, those light waves are actually coming from a different raindrop.
Are you serious? Well, then how do they work together to make an arch?
They don't technically work together. It's all physics. It all has to do with the angles. So the angle of the light that would reach your eye is in that arch shape.
Weird.
Yes. Let me see if I can find, let me see if this has it. Let's see if this picture works any better for you. And then we'll get to the secondary bow. So if you have a raindrop in each of these different spots for each of the different colors, those angles are just so because it's reflecting and refracting at very specific angles for each color. And you can sort of see down here, they have different degree measurements. Each color is going to reflect at a very, and refract at a very specific degree. And so each color is going to have to come from a different raindrop at a different height compared to you in order for that light to actually reach your eye. Which means that when you were talking about, and we looked at your pictures and the rainbow appeared to move with you.
Yeah.
Technically, you are seeing every time you move, you are seeing a unique rainbow, technically. It's not the same rainbow. It's your personal rainbow. And even if I was standing right next to you, I would technically be seeing a slightly different rainbow from slightly different raindrops.
Okay, you do need to now write a children's science book called Your Personal Rainbow. And that is very cool.
Isn't that cool?
Wow. I have more follow-up questions, but do you want to talk about the double rainbow first?
Let's do the double rainbow first, and then we can get to your follow-up questions. So you can see here in this diagram that the secondary rainbow does have drops in a different place, right?
Yep. Yeah.
But additionally, the secondary rainbow is actually doing, those raindrops are doing something extra special. If we look here, on the left side here, you can see this is the normal one that I showed you.
Yeah, so we're looking at a little diagram of a person standing with the largest raindrop I've ever seen above their head and to the side. And then we're seeing the sunlight go in and doing that whole like reflecting situation.
Yep. But here on the right side, this is what leads to a double rainbow. Now you've got the sunlight coming from a different angle. Now instead of going through the top of the raindrop, it's going through the bottom, and it actually reflects twice. Once, and then it reflects off the inside again another time, and then comes out at a different angle. And that is why, one, the second rainbow is in a different spot, and two, why it is fainter, because it's lost more of the light because it's reflected twice. And when it's reflecting, technically not all of the light is reflecting. Some of the light is getting out the backside of that raindrop. And so that's why it's fainter.
Whoa. That is so cool.
I mean, I think so. I think color is amazing.
That's really cool.
You got other follow-up questions?
Yes. So shoot. Okay, so if I'm looking at my little picture of my rainbow, where are the raindrops? Are the raindrops where the rainbow is? Or are the raindrops behind me? Are they above my head?
Okay, yes. Getting back to the location, if you look at both of these diagrams here for the primary rainbow and the secondary rainbow, where is the sunlight coming compared to where the person is in the diagram?
Behind them.
Behind them.
So that's real?
It's real. The sun has to be behind you and the rain has to be in front of you. Otherwise, the reflection doesn't happen the right way and you won't see it.
So those people driving the other way on the freeway actually do not see
the rainbow.
The rainbow.
Because the light is bouncing and reflecting off of the back side of that raindrop, which means it's being reflected away from them. So they can't see it.
And that's why you can never find the end of a rainbow.
Well, that's part of the reason why.
Because it's going to move.
And the leprechauns.
Okay, fair, yeah. Oh my gosh. Wow.
Yeah.
That's really cool.
Did you have other follow-up questions too?
No.
Okay. You're like, I got nothing else to say.
I'm good. I learned about rainbows.
Yeah. Yeah. A few other things that you mentioned that I also want to talk about. One of the things was you thought that maybe if you could get far enough away, you could see maybe a full circle.
Yeah.
And you could from certain places. You can actually, because a rainbow is only a bow because the rain isn't also then below you.
Oh, I thought it was because of the earth.
Right. The earth is in the way. The rain can't go through it.
Oh, okay. Okay. Yeah.
But if you're, say, up in a plane looking down and the angles are just right, you could potentially see a full rain circle. I have a picture, if I can find it, that is technically, it's not going to look like a rainbow, but it's the same concept. And this is a picture I took.
Oh, like a sun flare is what we might call that.
I mean, I wouldn't call it a sun flare.
Oh, did I just make that up?
No, you didn't. But it's because a sun flare is a very specific thing from the surface of the sun, which this is not. But we've got some clouds in here. You've got the sun in the middle. And then do you see the circle that goes around it?
Yeah.
And that is, and you can sort of kind of see
a little bit
of color around one of the edges. This is basically a full circle rainbow. It's called a halo usually around the sun.
Oh, that's what I've heard.
Yeah.
Yes.
And it's a similar thing, except it's caused by ice crystals in upper layer clouds. But it's a similar thing where you've got bending of light and it does it in such an angle that from your perspective, it goes all the way around. You can also see those around the moon in the evenings and night sometimes. I've seen those too.
That's very fun.
Yeah. So there is sort of a circle shape that you can get out of it as well, which, so again, normally you don't see a circle rainbow, but there are unique circumstances where you could, because yes, it would make a full circle shape if all of the pieces were in place so that you could see it.
That's really cool.
Yeah. And with that, it's time for your pop quiz.
Oh.
I mean, it's not really a pop quiz because you know it's coming.
Yeah, but it was more fun to just talk about rainbows.
We're going to talk about rainbows more.
Okay, fine.
First question. What ingredients are needed to make a rainbow?
Ingredients. Light and water.
Bingo. All right. Where does the light and the water have to be in order for someone to see a rainbow?
The light has to be behind you and the water has to be in front of you.
Great. Why?
Because of the specific angle that it reflects off the back of the water droplet. You'll only see it if you are positioned at that angle, which is like between the two and down.
Mm-hmm. Yeah. And that reflection off the back is kind of the key part of that. It's like a mirror. And in order to see the light, it's got to bounce off the mirror and bounce back to you. The water is like the mirror.
Nice.
Yeah. Great. What happens inside a raindrop that leads to the colors of the rainbow?
Refraction.
Ooh, you even remembered the word. I'm impressed.
I sure did.
And what does that mean?
It means that it splits up the wavelengths of light, and then we see them separately as opposed to together in normal light.
Yes, absolutely. And last question, what causes a double rainbow, and why is it fainter than the primary bow?
A double reflection is what happens in a double rainbow, and it is fainter because, I mean, when it's been reflected a second time, it's just not going to be as strong. There's less happening. Less light is reflected in the second bow because it's reflected twice. This is a partial credit. I can tell.
It is reflected twice, but that's not really a why, that's a what. Like, why does it being reflected twice mean that it's less bright?
Because some of the light goes through the raindrop.
There we go.
Okay.
Because not all of the light gets fully reflected. Some of it gets scattered out. Yep. See, you knew. It was in there. Just had to dig for it. Well, you still passed.
Yay!
And now you know more about rainbows.
I sure do.
And the next time you see them, you can impress someone with your rainbow knowledge.
And I can enjoy my personal rainbow.
You can enjoy your personal rainbow. And with that, we are out of time. So why don't you pack up your stuff and get ready for my closing remarks. You can follow us on Instagram and Facebook at I Slept Through Science, or on Twitter at Slept Science.
If you have dumb science questions like I do, please send them to us. You can email us at isleptthroughscience@gmail.com, or you can even send us a voice memo and we'll play it on the podcast.
Please rate and review our podcast to tell other people what you think about it, subscribe to make sure you don't miss an episode, and share about our podcast on social media.
Thank you to Beth Reed Miller for the artwork. You can check out more of Beth's artwork at Beth Is Something. Okay, great. Thanks. Bye.
The bell doesn't dismiss you. I dismiss you.